Hello again and welcome back to the programming bootcamp. My name is still Gabor Savo. Nóra, hi. And then switching to the slides. So just to remind you, this is the place where you can find the slides, where you can get to the slides. That was in the first video explained. And we jump ahead to the slide that we just stopped. So we talked about the conditional main, and we stopped that just before starting to talk about input and output. So in every program that you write, there is the program itself that does stuff, but it needs to get some input from the outside world, and then it needs to give some output. So in the previous programs, we just had output, printing something to the screen, okay, the result of some computation. But in other programs, you also need to have, in most of the other programs, you also want to have some input to work on some file or to ask the user to something or whatever. So in general, you can have, I just listed here a couple of things where you can get input from. So for example, you can get input from via the keyboard, okay, through the keyboard, which we call, and later we talk about it, either the standard input or the command line, or if it's a GUI application, so it has a graphical user interface, like we mentioned, the Word or Microsoft Word or something which is a graphical user interface, you're still using many times the keyboard to enter stuff, to type in some value and so on. You can also use the mouse as an input device, okay? We won't talk about that too much because it's a little bit different issue, although when we touch a little bit on the creation of GUI, of the graphical user interface, there you also have the mouse clicks that you somehow you can accept and do something with it. So it's either mouse or the touchpad or something like this. Then there can be touch screens. That's again something that we don't touch in this course, but we don't talk about it in this course, but that's also a way to get input to the program. Then there are the less interactive things like the files and the whole file system. So you will probably have some files, an Excel file or some text file or all kind of files that you want to process. And these are all inputs to your program. You could also get input through the network. So for example, if you write a web application, okay, a website, like think about whatever, Google or Gmail, it gets input from you. Through the network. So you are sitting in one computer, they have some other place in another computer, then through the network, through the internet, which is just one network, you send data. You don't need to care about it, how it's gone, but it somehow went over. And then the web application that can be written in Python, and we might actually get there because it can be a nice way to represent your actual work behind the scene. It comes through the network. So for all purposes, probably the main interesting part is to do all the computation behind the scene. But some way you need to be able to give the input to the computation, and you would like to make it convenient to the user, who might be you, who might be other people in your lab or some other places, and who might want to use it. So you might create a GUI application for them to run on their desktop, or you might even create a web application which can be accessed inside the lab from other computers, and or even from the internet. It doesn't have to be through the internet. It can be just other people in other parts of the institution. So the whole can be really in a small place in there. So these are the inputs, and then you have the output, which is, the screen, obviously. You put stuff out, you print things on the screens. You can again put stuff back into files, so your file system. You can send the stuff that you created, the output, through the network. You can also go and think to send out stuff to a printer, okay? And then you could also have to the input a scanner, if you think about it. So there can be all kind of other things. This is just a short list of things. The thing that my phone is beeping, I was wondering if I should be worried recording the video, but I felt that if there's no thing, the beeping and ringing, then people will feel that it's not like the real world. So it's okay that we have something beeping. I just won't pick it up. Anyway, so this is the general thing about input and output. And now let's see how to use output or some parts of output and then input in Python. And that's one of the things that change between Python 2 and Python 3. So in Python 2, you would write print, and then without parentheses, you would put some string there or a variable or something, and that would work. So you would just say print hello, and it would print out, or print foo and comma bar, and it would just print it out. Okay, so you didn't need the parentheses. You can notice the one thing that when you print out hello or world or foo and bar, then each print is printed on a new line. Okay, but when you print a foo comma bar, then it's a space between the two. So even though foo didn't have a space here and bar didn't have a space inside the string, there is a space here. Okay, and it's not this space, just to make sure. This space is just for me to make the code more readable. I could have put there 40 spaces, no space. For Python, it wouldn't matter. It would be just less readable for the code. This space is just added by Python because the things were separated by the print statement, because the things were separated by a comma. And so some people, once in a while, you wanted to, you wanted to print something, and then you wanted to make sure that the next thing is printed on the same line, not in the next line. And in order to achieve that in Python 2, you would put a comma at the end. So you see the difference here? Hello doesn't have a comma. Here it has a comma. So when I print it out, the hello, and then comes the word. Okay, not that interesting, especially because it's Python 2. That's even less interesting for now. So just let's skip over that part. The point here is that print in Python 2 has no parentheses. So when you look at some code, a piece of code that you encounter in the lab or download somewhere or search for a solution, and you encounter on Stack Overflow, and it doesn't have parentheses around the print, you can immediately know that, oh, this was written in the ages of Python 2, and if it doesn't work for me, I just put parentheses around it, and that's it. That part, at least that part will probably work. Maybe other parts not, but like this is one of the biggest things that people encounter, biggest issues. Okay, there are a couple of other things. So in Python 3, you would just have the same, just put parentheses around it. Okay, so but what would you do here if you wanted to make sure that there is no new line? Instead of putting that really strange ending comma, which was really like strange, why would a comma at the end have such a meaning? Okay, instead of that, now print is a function. So because of parentheses, you know that it's a function, and it can get parameters, and one of the parameters can have names, and one of the parameters is called end. And so I say here that the end is equal to a single space. So now when I run it, you see that the output is going to be hello space world. So the hello, then this space and world, without a new line after the hello. The thing is that the print function has this parameter called end, and by default, it's a new line. If you don't give it, you don't give to print any parameter for end, it will just print a new line at the end. Okay, so it will go to the next line. And you can optionally say that the end is now a single space. Let me show you now. Let me play this a little bit. So examples, basics, prints, no. Oh, I don't know how I'm going to edit this now. Okay, so let's do some editing. I open Notepad++. Okay, just opening and then now going to look for the file. Open. Now it's in the, where is it? It was in this PC. Okay, the C drive. Okay, sorry for searching users, Gabor Sabo. It was work. Slides. Python. Examples. Basic. Sorry. Basic. In Linux, it would be way simpler for me. But okay, and what was the name of the file? Do you remember? Because I don't. Print3, no new line. Okay, so it says print3, no new line. Okay, I think this was the file. Okay, and I can switch to the Amaconda prompt and seed into the basics and run Python print3, no new line. So this is the file, right? I think this is the file that I'm editing here. And I could put here something else. So I could remove the space from here, let's say, and save it, and then run it again. And you see hello without a space world. Okay, so this, I can put here a dash, save it, run it, and then it puts it in a dash. Okay, so it just helps. Let me put it back to the original one. It just helps us to set something instead of new line. Okay. There's another thing here. If you are already scrolling down on this page, so you know the end that can be, let's say, the empty string, and there is also another parameter that you can give. It's called sep from separator. So normally, if you have a comma, that will become here, like here, for foo bar, and then it's gonna be a space. So this is the default of sep. But you can say that the sep is now an empty string, and when it's printed, you see that foo and bar are together now, no space. Okay, these are just small things, but the issue is that many functions actually can get parameters, all kind of parameters. Usually, so here you can see one parameter that we passed, which has no name, just the first parameter, and then another parameter that has a name actually, called end, and the value. Okay, so that's just the difference between the two prints. So what happens if yeah, okay, that's another, right, sorry. Okay, so this is an example of code that can help, especially when you have a bunch of code that's written for Python 2, okay, and you would like to move over to Python 3 because the rest of the code is already Python 3. Then you want to make slowly the changes that your code will look like Python 3. And so Python 2 allows you, Python allows you to use this piece of code, which basically says that from the future, bring in the new print function. So it was added to Python 2. It was like a back to the future moment, okay? So it says basically, okay, we know that in the future, when you will go into Python 3, you will have a better print function. So we say, okay, from future, bring in the print function. And this replaces the print. So now we have the print function, just as if it was in Python 3. So if you encounter this kind of code, then you will know that, oh, someone in Python 2 was trying to pretend they are using Python 3, at least for the print function. Okay, this can be also a good solution for people who are trying to move from Python 2 to Python 3 to be slowly add on the functionality. And if you run the same code in Python 3, no problem, because you are already in the future. Okay, and then it just does the same as normally. Okay, so what happens, and this is another interesting thing, what happens if you run a program that has print hello in it, but you're using Python 3? So back to this is like the standard program. What happens if you give this program to someone who has Python 3? Python 3 will say, okay, it's not what I'm looking for. Okay, I don't understand what is print without parentheses. And this is how it will look like. Syntax error missing parentheses, so it's pretty clear in the end. In hello to print, did you mean print? So in the end, it's pretty clear that's gonna be the thing. On the other way, if you just code Python 3 code with Python 2, and you have the parentheses, it's more or less the same. So that's fine. Okay, so this is the one part, the printing part, which is already we saw how to print. Now it's a bit more well defined or whatever, and especially you know the difference between 2 and 3, which hopefully you won't encounter. But if you do encounter that, you need to you can remember of this. So how can we ask the user for some input? And here too, there is a difference between Python 2 and Python 3. So in Python 2, you had a function called raw input. And raw input, you would give it a string, and it will ask the user, it will print out that string, you will prompt the user to type in something. So here is on the command line. So this is now everything on the command line. So it's called prompt2. And let me try to run it, although I have Python 3. No, okay, it won't run. Okay, so I won't be able to show you. But I will actually show you what happens. So this is what you can see. So if you happen to run the code above that has the raw input in, you run it on Python 3. So that's when I can actually show, to be sure. So Python, and it's called prompt2. Okay, and this is what happens. So I'm trying to run with Python 3 some code that has raw input, the function raw input that was in Python 2, and it says name error, raw input is not defined. Now it's a pity, I think, that they didn't have a special error message telling us that, oh, you're probably having moving from Python 2 to Python 3, and that's the issue. But well, this is like a more generic error message. Okay, you don't have this raw input thing defined that you were using at this place. So go and understand why is the source. We can understand that the source is that someone is using Python 2 code in Python 3. Now, just something about the slides. You see here this prompt2.err. Sometimes you see something.out. These are just files that I took the original output, saved it in a file, so it's going to be easy for me to include in the slides. You don't have to really care about all these .err files. These are just help. At one point, maybe I'm going to just hide these file names, okay? That's going to be clearer probably. But if you ran this program in Python 2, which I could do if I was on Linux, here I just have the Python 3 installed, then it would run this and as soon show the same thing in Python 3. Okay, so we can see how it actually behaves. It would print, we have a question, because we have a question, and then it would print your name, colon, because it says here your name, colon, and it would wait. It will wait till I type in something and press enter. And then whatever I typed in gets into the name variable. And then in the next line, I print it out. Hello, whatever I typed in. And I typed in foobar because that's my nickname, whatever. And prints out how are you, which is just the text here. So let's see it's actually in action. Next slide, which is now the implementation for Python 3, where I use the function called input. Okay, so this is called prompt3. I can run it Python 3 py and run it, and you can see it printed out we have a question. Maybe I need, yeah, maybe it's better if I just make this a little bit smaller. I heard from people watching the videos that sometimes they can't see the bottom of the screen because of the management tool of the video and show the thingy. So I'll change it a little bit. Okay, so that's how you can see it. I ran the program. It printed out that we have a question because it was a print statement. And then the input statement printed out the text it had it in. And now it waits. And now I can say, actually, I'm called, now my name is Gabor. Okay, and I type in and I press enter. That's when the program continues running. Okay, so until I don't press enter, nothing really happens. And then whatever I typed in gets into this variable, which can be any name, any string. So it could be, again, it could be first name, last name, full name. I just use the word name here. And then I print it out. And in this case, I use the plus operator to concatenate them. I could use the comma just to print out one after the other.
Yeah, I was going to actually ask you what's the difference between those two.
So
here.
In this case, it doesn't really matter. I think it's a better example that I'm using here, plus. I think it would be much better to use comma in these examples. So I'm going to fix it. So if someone is going to look at the slides later, they will already see a comma and they will miss out this discussion. So the plus operator concatenates the strings and then gives one string to the print, which then prints it out as it is. If it had commas, then it would give 3 things to the print statement, and it would print out the first one, then put in a space, then the second one, then put it in a space, then the third one, which is slightly different. Now I had to worry about the spaces. You see, I put in hello space, and here I put. I don't have a space here, okay? But I had to put in the space, so it's gonna be printed.
But this way, if you're using the plus signs, can you use the separator function?
Yeah, you can see and, right, sorry. You can still say and then say that be something in there. Yeah.
Right. Okay.
But now you don't have, but now it doesn't have so much meaning because you have a single parameter.
Right.
So the and won't be applied to the plus sign. It would apply only to the pieces that you send into the print function. But because in this case you send in a single piece, the separator doesn't have a meaning.
Yeah, so because of the plus signs, it becomes one string instead of 3 separate strings, right?
Exactly.
Okay.
Exactly. Right. So this is what happens, and I just wanted to show what happens if. Right. Now this is horrible. Okay, this is horrible, but I have to show it. So what happens if you run the Python 3 program? Okay, so the program that was written for Python 3 using the input function, and what happens if you happen to run it on Python 2? Because this is actually bad. Because Python 2 also had an input function, but that input function, it hid behind the scenes 2 things. First step, it called the raw input. So far is fine. But then it took whatever you typed in and said, oh, I assume that this is some new Python code, and I will run this as if it was a new Python code. So what happens here that it says that it has a syntax error, foo bar, which looks totally meaningless to someone using this, right? I just typed in foo bar. What is a syntax error there? Okay, but this is because Python, in this case Python 2, tried to execute this thing as Python code. Now, unfortunately, I can't. Do I have this? No, I don't have. I should really have an example where I type in some actual Python code. And you see that, oh, it actually executes that code, which means on one hand, it's really nice. I can give in input and I can, it's more flexible, right, great. But it means that if I don't control the source of the input, then the person who types in that thing can actually execute anything on my computer. So they can just type in, oh, remove all the files. and then you just execute it, remove all the files. So it's an extremely it's a security issue, and I don't know how Python got away from it for so long, but that's one of the reasons it got fixed in Python 3. Okay, so don't use input in Python 2. That's sort of the lesson. And well, it's better to protect your code that if you're using input, it's better that your code will check, and I showed it earlier, how to check if it's already on what version of Python you're running, and say, no, this code needs Python 3 at least. Please go away, find a Python 3 and run it on it. Okay? Questions here? Okay.
No, I think all good.
Okay. Yeah, so this is what I just more or less said, but with less words. Always use row in Python to always use row input and not input. Okay, so this is just let's go over this if it's already here. So this is all, and jump over if you don't care about having code between 2 and 3 and working on both. So this is a piece of code that can work on both Python 2 and Python 3. Okay, in case you would like to write it manually something. Sometimes it's important. What it does, it imports the print function, so the print function will work on both. So I won't have to write it twice in 2 different ways. And I import the sys module. I check if the major version number that we saw is less than 3. Well, it could be 2. It could be also 1, but I mean, if someone is using Python 1, sorry, someone is beeping me all the time. Okay. So if someone is using Python 1, that would be really, really strange to me. So Python 2 is, so this is the if condition. So it says if the major version number is less than 3, so it's 2, then use row input. And if it's otherwise, okay, so it's like English in the end, just slightly strange to read it, but it's basically English. Otherwise, so else, call the input function. Okay, so this code would in the end work on both versions of Python and would print out the name. Of course, there are tools, much better tools to do this, but I thought that it can be an interesting example to show that you can actually write code if you really, really need to handle both. Now, Python 2 is already out. I mean, I wrote this like 2-3 years ago when it was still a much bigger issue. Today, in reality, today we'll still have lots of places where they still use Python 2. I even encountered a company that just recently started some project using Python 2. It's unfortunate, but that's the reality. Okay, so we have to be sort of ready for this. And especially, I think in the scientific world, people, at least in this area, they tend to be conservative. Okay, maybe they do extreme research on extremely new things, but when it comes to programming, in many times it's just, oh, we have been using it for 20 years, still using it. Okay, so now let's start using this input before we get to some exercises. So we have a function here, the main function, that what does it do? It asks the user for a number, gets the A, and then asks the user for another number, puts it into B, and then adds the 2 numbers together and prints it out. Okay, it doesn't even put the result in some third variable, it just prints out the result directly. So what happens if I run this? And I can show you actually running it, but I can show you it's already here on the slide. So I typed in 2, I typed in 3, and the response was 23. So why is that?
I suppose it concatenated the 2. Does it? Maybe it handles them as strings then, instead of numbers.
Exactly. I mean, how would Python know that what I typed in is a number?
Right.
Just
Fair enough.
because I had some text here, no, that won't matter. Just because it looks like a number, well, you know,
You can never
can,
assume.
yeah. So, and that's always an interesting question, by the way. What can you assume and what you don't want to assume? And if you assume things, that will be more easier to use for many people, but they can fall into mistakes much easier as well. So it's a trade-off on how much you invest in this and how much you say, okay. So this is the problem, that they are, whatever I get from the user, the input, it's going to be treated as a string, even if I type in the number 2 and the number 3. So what can we do? Well, we can use the int function to convert the string into an integer. Well, we assume here actually that the user typed in something that is an integer, because this would freak out if I give it a floating point. But yeah, so but for integers it works. Okay, so you can use the int function to convert it. Now, make sure that it's clear that, let me make sure that it's clear that it didn't change A. A is still a string. What it did, it changed the content of A to be a number. Not whatever was in the A, it changed it to be a number. And then we used it in the plus operation. But if in the next line I ask what is the type of A, it will be still string. So because I didn't assign back to A, I didn't tell Python to, oh, put into A something that's now the numeric version of it. So it didn't apply the change to A. Okay. Anything else here? I think it's okay.
No, I think this is quite straightforward.
Okay. So similarly, by the way, I don't think that I have it here somewhere. Similarly, you can have a function called float, or there is a function called float that can convert, assuming that there's something outside that looks like a floating point number, can convert it into float. And then there is the nice question: what happens if you get it in a float, but you actually want it at an int? It's a little bit of a mess, but you'll figure it out. Okay. So how can I check if the given thing that I was given is actually can be converted to an integer? One way is actually to try to convert it, and if it blows up, then it wasn't. Okay, and then to learn how to capture these errors that we can encounter. And the other way is to use this function that you can use on the val. So on this variable, now that I code val, that I got from the user, I print it out, and then I can I can print out the value of whatever the is decimal returned. So let me try to run this, the is number function, because apparently the output here is not what no, sorry, it's right. So type in a number, that's what is printed out, 42. I typed in 42, and then it printed out the 42, so it's not here. Yeah, that's not good. So the output here is not right. Okay, let's try it. Is number. Yeah, there are problems with the slides. Python is number. So here, let's try 42. So this is the output. Okay, so it says 42. That's the output, and true, and then 42. So let's get back to the code. The is decimal returned as the value true. So this is a decimal number. The is numeric also gave us true. And then in this condition, I said if is decimal, then convert it into as an integer, and then print it out. Now in the output, you don't see that this is a number and this is a string, right? They look the same. So it's important to know that what is what, because from the output, it's usually hard to say. So let's run it again. Let's give it 4.2. Okay, so what happens now? It says, well, it prints out the value. Both are false. So it says it doesn't even think that it's a numeric value. Okay. And what happens again if I type in 3, but in, sorry, that doesn't matter. The parentheses, it don't matter. I just, don't worry about that. So what happens if I type in a text? Then it says, okay, hello, they are both false. So you know that it's not a number, you can't convert it. Okay, so there are other ways to check something, an input, and many times you're going to use what we call a regular expression, or regex. We're going to learn about them. It's a very, very powerful tool to verify if a string looks like something that you wanted it to look like. Okay, it's not just for numbers. You might want to, I don't know, you get in an input, a string of a DNA, and then you say that I only have these 4 letters I want to be in there. But maybe I also allow for another letter X just to, I always forget amino acids, right? So only those 4 letters. Correct me if I'm totally wrong, because that's
no. Amino acids are in proteins. These are bases.
Bases. Okay, thank you. So I'm just showing my total lack of knowledge of anything chemistry or biology or whatever. So the 4 bases, and then, but you might want to allow for other signs to mark things that you don't know, or I don't know, whatever. So you can use a regular expression to check, to verify that actually that's what you have in the string. Only those things that you allow. And maybe you want to have it, later on we're going to talk about regular expressions for stuff like, okay, you want to find a DNA that has a repetition, all kind of interesting things, okay? But for now, I'm just saying that that's another tool that we can use. Okay, so the other thing that you can do is wrap the whole thing in a try except, what I said, that you let it blow up and then catch the well, explosion, the exception. It's called raising an exception or throwing an exception. That's the word. We'll talk about this as well later, because we'll need to use that in all kind of other places. For now, here are the things how you convert in the end a string to an int.
Can I have a question just
Sure.
quickly? So previously when you typed this all in and you typed 4.2 as the number as you wanted to give in, how come it didn't realize that it could be a float number?
Yeah, that's a very good question. And now it's really, really bad that we are recording it, because I don't know the answer. And this is the right place when I say, okay, I'm going to check it and I get back to you. Okay?
Right,
So,
okay.
so I'm going to, thank you for asking this. I tried to skip over that part. I mean, I recognize
Sorry.
that there is an issue with this. Yes, all right. So I'll have to check it actually,
Okay.
because I don't actually know what is the reason. Okay.
Mm-hmm.
Okay, so let's go over to the thing that I might know. So converting a string. So here we have a string. So remember, we have this type function that can give you what is the type of something. So it says, well, it's a string. It now says that the class of string, well, it's because everything is wrapped up in this. So a class is something that can describe some object in a more general way. We are going to talk about this for now. Don't worry too much about this. This is just wrapping something around. Actually, it has some relation to the classes in biology, so definitions of things, but not much, and probably less than I think. So use the int function, and then you convert it into an integer, and so now you, in the output, when you print it out, they look the same. But when you print out the type, now it says it's class int. So Python already knows that this B is of type int. And what else do we have for? Okay, so here we have another string that starts with a number, but it's still a string. And if I print it out, then it says that's the content. The type is string. If I try to convert it, then this is what the exception I get. So that's what said that it can blow up. It raises an exception, it stops the program, and we can capture this, and we'll later learn how to do this, so it won't stop the program. So in the program, we can capture this. And that's an whole interesting story how to do this. But for now, that's what I just wanted to show. Now, if you have a floating point number, you can type it, it's a float. You can convert the floating point with the same int function into an integer. So it's taking the integer part only, and also changing the type, okay, to be an integer. And if you get a string which is a floating point number, so that's basically what we had earlier, we got from the output, and it's a string, okay. If you try to convert it into an int, that doesn't work, okay, that will blow up. Even though you could convert it into a flow, and then you can convert it into an int. But if you try to directly convert it into an int, it won't work, okay? So luckily I didn't really have to deal with all these things. So it's slightly esoteric what I'm showing, which is probably not a good idea, but I got into this mess anyway. So here I have this string, I convert it into a float, then I convert it into an integer, and now I might be happy because A is a string, B is a float, C is an int. Okay, so I can do this. I could do it in one step. Okay, I don't think that I've ever written anything like this in real code just for this slide. So it's an interesting thing because you might need to deal with these things when you deal with input. A much more interesting thing is the if statement. Okay, so we'll show it for a second earlier. In general, but more or less so far our program proceeded one step after the other, no matter what happened. Sometimes you will want to have conditions. So if the user gave in this input, then I do this. If the user gave that input, then I do something else. Or if it's Sunday, I do this. Otherwise, I do something else. Or I write in a file, and in the file I have some condition, some data, and based on the data, I need to do different things. Okay, so the general way to do this is to write if, and then you write some condition. So for example, you can check whether this object equals to this object. And notice this is two equal signs. So here I had an assignment, which is a 1x equal sign. And if I try to compare the two things, that I use two equal signs. That means that compare the two and give us a true or a false, depending on if they are equal or not. Okay, and then after the if statement, there is this colon, and then whatever happens if the condition is true is indented again to the right. You could have actually several statements here, one under the other. So if this is true, then do this and this and this and this, several things. That doesn't matter, but they all have to be indented to the same depth, which is again recommended to be 4 spaces. Okay, so that's it about if. Any questions here? We have a couple of more slides about if, but no.
No, I think it's all good.
Okay, yeah, so it's rather simple, more or less English, slightly different syntax, but sort of.
Actually, one question.
Right.
So if you don't use anything else, only the if, and there is nothing coming back, like the if statement that you gave comes out false.
Yeah.
What does the program do?
Right. So I should actually edit this program so you'll see something interesting there. Examples basics if by. So let's try to open this program, and it's called if by, and that should be a correction to this program, and print this happens. Okay, and so now if I run this program Python if pi, then what is my answer? So if I say 42, it says welcome to the cabal. Okay, this was the program, right? Okay, and if I say 23, then it still says that this happens.
Right, so it skips to the next line.
Yeah, so basically, and it's a good thing that you're in England, because my standard example is that you can walk by and say, if it's raining, I open my umbrella, right? But you don't say, otherwise I don't open my umbrella. You just don't say it, right? So there are cases, we just keep walking. So that's basically what happens here.
Right, okay.
So it just goes to the next thing that is under the if. So, okay. And I'm just putting it here so it can be easier to show that that you can have several statesmen there. Okay, you can have one or more statesmen there. Okay, I'm going to update the slides with this later on. Okay, where are we? Where are the slides? Here. Someone is still want to talk to me. Maybe it's a sorry for that. Okay, so right, we have this if statement and then nothing. Okay, so otherwise nothing. But of course, we can have this other thing that if I want, I don't know, if whatever happens, then go right, otherwise go left, and you actually want to say the otherwise part because you want that. Here too, I would probably want to edit this one. So here too, I'm going to edit this file, and it's called if else. And here still, I would like to print still here, okay? So what happens is then, if the if condition is true, then this part is executed. And then we go on to this one. Otherwise, and right, I'm using another word for else, right? Otherwise, just to explain it. Else, I do this. Okay, and then we go on here. Okay, so it's just two branches. So the interesting thing is, and in both cases, you have two branches of doing things. Just in one case, you actually don't do anything in that branch when you only have the if. Okay, and here I do to actually separate things. And it totally depends on what you need to do. Okay. Why do I have the other example? I don't really remember. Why do I need to? Okay, that might be a slightly useful example. Is that when you have this brilliant program that can divide a number with another one, and then you say, but I know that it can't divide by 0. So instead of just letting it divide and blow up again, okay, and you remember that it will throw an exception that's saying, okay, it's division by 0 because it can't do it. So instead of that, I'm going to protect my program and the user of my program and say, okay, if the, whatever is it called in English, division, the one that you are divided with, okay, if it's 0, then just print, say, cannot divide by 0, okay? And otherwise, you go on and do the program, okay? So that can be really more useful. Okay, so that's now getting a little bit deeper here. So let's say we have two numbers and we would like to print out which is bigger or if they are equal. So now we actually have three possible outcomes. So we need two conditions for this. And this is one way to write it. We say if A equals to B, then do something. Else, and then now we have another condition inside this. So this is indented, okay, because we only have to ask this question if we know that they are not equal. Okay, and then we ask this question, is the A less than B? And if it is, then we print out that, otherwise print out the other one. Okay, so this is a perfectly good way to write this. Three conditions, so two conditions, actually three outcomes. But, I mean, it works. The only issue is that the general consensus is that whatever is more to the right is less important. That's sort of the general consensus of programmers. To the point that many programmers don't even bother to read whatever on the right when they're reading the program. They're just skimming down the program, and whatever's on the left side they understand, and then the rest is sort of, they forget about it. So if you would like to actually send the message to the next programmer who is going to maintain this code, that these are actually three totally, that the level of importance of these three outcomes is totally the same. I just happened to check the condition first because that's what came to my mind first, okay? Doesn't have any meaning. Then there is another way to write this, and this is how to write it. So you can have this elif operator, which actually comes from else if, but this is how it's spelled in Python. And then you can say that if something happens, then do this. Else, but if this happens, do this, else do this. So now it functionally is exactly the same. So it will do exactly the same as did earlier. But now the message to the reader of the program is that these are basically three equivalent outcomes in terms of importance or likeliness, or I don't know, whatever, not likeness, but yeah, importance, let's say importance. So they are on the same level. That sort of comes from the message, okay? Which actually brings me to, again, to some, actually, I think I told, no, I didn't say it yet, that most of us programmers or people writing programs, I mean, even people who don't think about themselves but as programmers but write programs, sort of think that, oh, I write the program, the computer understands, I'm done. And unfortunately, that's not the case. 90% of the time you spend with your program is later on editing it. So only was like 10% was the first time you wrote it. So it's extremely important to make your code easily maintainable, to make it readable, to make clear your intentions and so on. And this is really, really hard for, especially, I mean, for everyone basically, because we are in a rush. We would like to get, oh, we're done, it works, so I don't want to think about it now anymore. But then I have to come back to it a month later, and suddenly it's a mess because I don't remember anymore. What did I do? Why did I do? And so on. And one of the things that I actually am not doing it here correctly, but well, it's a small example, is to give meaningful names to your variables. So using A and B has no meaning, okay? Yeah, this is a small example, and really I didn't have any good explanation for these variables, but whenever you know then what is in the variable, then give it a good name that explains to it. Okay, so there is also something called the ternary operator in Python, which looks like this. So it says, okay, so basically it says this: give to the answer the value positive if this condition exists, otherwise give it the value negative. Okay, I could use it in else, I could use the word else, but then I would totally reuse the same words. So if I scroll down the ternary operator, this is basically this code. So it says, if x is greater than 0, then put positive in answer, else put negative in answer. Okay, so which is not even correct because x equal to 0 is not negative, but let's forget about that part now. Okay, so but code-wise, these are the same, and this is just a one-liner for this, and so many people like this expression because of that. Okay, and the funny thing is that I also used here the word ternary operator, which is many people use this operator, the ternary operator, but it's actually the word ternary just means that it has 3 parts. Because most operators, like a plus sign, right? through 2 plus 3, okay, it has two operands. So therefore it's called a binary operator. And you can put, because it's of 2, you can also write -3 just out of the blue without saying something -3. You can just say -3. So minus can be also a unary operator. It only has one operand. And there is only one operator that has 3 parts. So the poor operator doesn't have a name, actually. Everyone just calls it ternary operator because it's the only one that has 3 parts. Okay? Actually, I think the real name of it is the comparison operator. But very few people actually use that name. So we all just call it ternary operator because it has 3 parts. And one day someone will come up with another operator with 3 parts, and then it will be a total mess of explaining things. So yeah, I just have the same example here again, nothing really. So that's the ternary operator, can be really useful. In some languages, there is a tool called case or switch. In Python, you don't have it, so we don't have to worry about it. That's good. We can skip this slide right away. I'm just having this slide here because many times when I teach people who actually have programming background in languages where you do have, they start to get frustrated that they don't find it. So I'll at least tell them that don't search for it. There is no such thing. Okay, so let's get to the exercises. I quickly go over the exercises and then I'll stop this video and let you actually do the exercises. So the first one is the rectangular. Yeah, so we had earlier this rectangular already, right? But we had the values inside the program. Now just take that same program and change it so it will accept it from the user the input. Okay, basically this. You can do the same for with the circle. If you circle, yeah, circle. You can do the same with that if you'd like to practice something more. And there's also the calculator. We also no, this wasn't exactly the example. So write this program that's like a calculator. You run it, it will ask you for 2 operands and an operator, and you can deal with the 4 basic operators. So that's enough work, and then it will give the result. Okay. So again, it's not something extraordinary. It's just a lot of work, a lot of unnecessary work, but that's basically practice. So that's how people get used to these things. Oh, and one thing here about getting used to these things. So there is a book called Learning Python the Hard Way, which is a funny title. I read a little bit of it. As much as I understand, the main point of that book, and I think it's a really good idea, is that you don't copy paste anything. You type in everything yourself. And the reason for that is because in programming, you really have to take care of everything really small. As I mentioned, every dot, every space matters. Every error message gives you some help. And especially at the beginning, to make it harder, to make it on yourself, basically, but you learn those small things, and then later on, these things will be already automatic for you. So that's sort of the idea. And that's why I also give exercises which are not too complex, though it depends a lot. So if someone is totally new to programming, for them it might be difficult. I'm not saying that's like totally easy for everyone. I'm saying that on the scale of all the programming, this is like the beginning of it. And then you're going to be able to do it. I'm not just talking to you now, Nóra, in general in the screen. Okay. Right. Okay. Okay. Sorry. I just remembered what was this exercise. So I managed to give 2 exercises with getting in data from the standard input. So that's what we call when the program asks you a question and you type in the answer on the command line, we call it the standard input. So that's what you type in. So it's marked. Sometimes it's written stdin, standard input. So you can feel free to come up with any other ideas, exercises besides of the rectangular circle and calculator that can be interesting with the current knowledge, your current knowledge, and using the standard input to practice. Okay, and I can then add it to the slides once we have more exercises. So any questions here before we go to the break? And I mean, I go to the break and you do the exercises.
No, I think it's all good.
Okay, so thank you again for watching this episode, and we'll have the exercises, and then once you have the exercises, we come back and continue. Probably we go over the exercises again, solutions actually, and then we go on and through the next chapter. So see you next time.
See you.